Hey guys, Jim here. Welcome to another SPI board review. Today we're going to go over some questions that you can expect to see on your upcoming boards. So let's get started. Question 1. What changed to make the Doppler image of the left look like the image on the right? A. The PRF decreased. B. PRF increased. C. Packet size increased. Or D. Packet size decreased. So what changed to make this image here look like this image here? The answer is D, the packet size decreased. Packet size or ensemble length is the number of pulses per scan line. So in this image you have 4 pulses, this image you have 3, so the packet size decreased. Question number 2, click on the artifact. So where would you click on this image? The answer is right here. This is called the mirror imaging artifact. Question 3, which of the following has the highest dynamic range? A, narrow dynamic range. B, bistable. C, low compression. Or D, grayscale. The answer is D, grayscale. These other 3 options here indicate a low dynamic range. Question 4, which of the following will degrade lateral resolution? A, multifocusing. B, focal point. C, fill-in interpolation. Or D, Fraunhofer zone. The answer is D, Fraunhofer zone. Question 5. Click in the area where the wall filter is too high. The answer will be anywhere where it's anechoic. Question 6. Which of the following will improve temporal resolution? A, high ensemble length. B, changing depth from 9 centimeters to 15 millimeters. C, high line density. Or D, pulse inversion. The answer is B, changing depth from 9 centimeters to 15 millimeters. This is actually decreasing the depth. So if we convert 9 centimeters to millimeters, this is going to be 90 millimeters. So you're going from 90 millimeters to 15 millimeters, which improves temporal resolution. Question 7. In this normal ultrasound, why is the middle vessel void of color? A, angle of inclination is 90 degrees. B, wall filter is too high. C, color gain is too low. Or D, PRP is too high. And obviously I gave away the answer on the earlier question. A lot of times on your SPI boards, they're going to answer questions that you already answered previously. You might have some repeat questions, just worded a little bit differently. For instance, this one is saying why this is void of color, whereas the previous one is asking you to click on the area where there's a high wall filter. So the answer to this is obviously B, wall filter is too high. Question 8, Click in the area where the PRF is too low. The answer is going to be right here in this aliasing area. Question 10. Which of the following will degrade color Doppler temporal resolution? A. High ensemble length. B. Decrease in the color box size. C. Fewer pulses per scan line. Or D. Placing color box in superficial region. The answer is A, high ensemble length. When the ensemble length increases, that means you have more pulses per scan line. Question 11. What changed to make this 2D image of the left look like the image on the right? A, PRF decreased. B, PRF increased. C, ensemble length increased. Or D, ensemble length decreased. Obviously, you can tell right away that this has 2 pulses, where this has 3. So the amount of pulses increased. Now, because this question said 2D image and not color Doppler, we know that ensemble length and packet size are not related. So this has to be PRF. So we went from 2 pulses per second to 3 pulses per second. So the PRF increased. Question 12. Which has the greatest tissue heating? A, M mode. B, pulse wave Doppler. C, continuous wave Doppler. Or D, power Doppler. The answer is B, pulsed wave Doppler. Question 13. Which of the following will degrade lateral resolution? A, smaller packets. B, lower quality factor. C, smaller diameter PZT. Or D, temporal compounding. The answer is C, small diameter PZT, because this is going to use a lower frequency, which will cause the beam in the far field to diverge more rapidly. Question 15. The speed of sound through a pulse wave Doppler PZT crystal increases how? A, density of the medium. B, thick PZT crystal. C, thin PZT crystal. Or D, smaller diameter crystals. Be very careful with these type of questions, because this is talking about the sound wave through a PZT crystal, not through the body. The answer to this question is a thin PZT crystal. So the thinner the crystal, the higher the frequency, which means the higher the speed. So like I said before, the thickness and frequency are inversely related, but frequency and speed are directly related. So higher the frequency, the faster the speed, and vice versa. Question 16. Which transducer has the greatest superficial imaging? A, vector. B, phased. C, linear. Or D, convex. The answer is C, linear. Question 17. Which of the following degrades axial resolution? A, damping layer. B, shorter pulses. C, decreased sensitivity. Or D, high quality factor. The answer is D. High quality factor will degrade axial resolution. You want a low quality factor. And these three will improve axial resolution. Question 18. Why is the area void of color indicated by the arrow? A, angle of inclination is 90 degrees. B, wall filter is too high. C, color right priority is too low. Or D, PRP is too high. The answer is A, angle of inclination is 90 degrees. The reason why it's not wall filter, color right, or PRP is because all the other vessels are filled in with color. But this area right here is 90 degrees to the scanning line. Remember, in a convex probe, where it's blunted at the top, the scanning lines will come down like that, kind of spread out. And the same applies for color Doppler. So this line here is 90 degrees to this area right here. Question 19. Which transducer is best for 3D imaging? A, matrix array. B, 2D array. C, 1.5D array. Or D, 3D array. The answer is B, 2D array. Question 20. What was adjusted to make the image on the right look like the image on the left? A, higher frequency transducer. B, PRF increased. C, wall filter decreased. Or D, color gain increased. So what happened to make this image here look like this image here? Don't be distracted with the different colors here. Just look at the uniformity or how much the color is filling in the vessel. Just because this is blue and this is red does not matter. All we care about is how this image changed to look like this image. You can kind of see that this image here obviously looks more optimal than this image. The answer is this image was taken with the higher frequency transducer. Question 21. What was adjusted to make the image on the left look like the image on the right? A, color right priority increased. B, PRF decreased. C, ensemble length increased. Or D, wall filter increased. Or what was adjusted to make this image look like this image? The answer is D, wall filter increased, because wall filter and PRF go hand in hand. So if wall filter goes up, the PRF goes up. Question 22. What does a matching layer do? A, increases the percentage of sound transmitted in and out of the body. B, provides a similar impedance to the PZT crystal, allowing the pulse to move away from the patient. C, protects the patient from electrical shock as ultrasound transmits into the body. Or D, provides a channel between the PZT and the ultrasound system, causing ultrasonic waves with vibration. The answer is A, increases the percentage of sound transmitted in and out of the body. Question 23. What was adjusted to make the image on the left look like the image on the right? A, PRF increased. B, ensemble length decreased. C, higher frequency was used. Or D, packets decreased. The answer is A, the PRF increase. When you increase the scale, this number here on the top and below, you're increasing three things: the PRF, Nyquist limit, and the wall filter. So what you do is you increase your PRF to eliminate aliasing. Question 24. In this patient who has a vessel obstruction, what adjustment was made to the Doppler image to make it look unobstructed on the right? A, PRF decreased. B, wall filter increased. C, packets decreased. Or D, color gain increased. So this is the obstruction right here. Why does it look unobstructed here? The answer is D, the color gain increased. Question 25. Why are some vessels void of color? A, PRP is too high. B, wall filter is too high. C, angle of inclination is close to 90 degrees. Or D, color gain decreased. The answer is B, the wall filter is too high. Question 26. Which transducer is best for 4D imaging? A, matrix array. B, 1D array. C, 1.5D array. Or D, 3D array. The answer is B, 1D array. Question 27. Which technique results in a 3D image? A, surface rendering. B, harmonics. C, elastography. Or D, spatial compounding. The answer is A, surface rendering. Question 28. Which type of transducer can control the elevational slice thickness? A, 1D array. B, vector array. C, matrix array. Or D, convex array. The answer is C, matrix array. Question 29. Which of the following will have the best LARD and LADA resolution? A, 5 megahertz. B, 10,000 kilohertz. C, 9 megahertz. Or D, 9 million hertz. This is where it gets important to recognize and be able to convert from one unit to the other. So this right here is the correct answer, 10,000 kilohertz. So when we convert 10,000 kilohertz to megahertz, it's 10 megahertz. 9 million hertz is 9 megahertz. So the highest frequency here is 10 megahertz, which will give you the best LARD and LADA resolution. LARD is axial resolution, and LADA is lateral resolution. Question 31. Which of the following will degrade axial resolution? A, low pulse repetition frequency, B, wide bandwidth, C, low frequency, or D, short spatial pulse length? The answer is C, low frequency. These other choices here will improve axial resolution. Question 32. What changed to make the bottom left image look like the top right image? A, PRF increased. B, sample volume angle increased. C, wall filter decreased. Or D, changed from a low frequency to a high frequency transducer. So what changed to make this image look like this image? The answer is B, the sample volume angle increased. You can see in this image here that the angle is 34, and in this image is 57, so the angle increased. Question 33. Which of the following has the lowest dynamic range? A, low contrast, B, grayscale, C, high contrast, or D, wide dynamic range? The answer is C, high contrast. And the way I remember it is if I have a high contrast, that means I can see the borders of black and white really well. If I have a low contrast, I can't see the borders very well. So a high contrast means that you're going to have less grays and more black and whites. Question 34. What's the best way to reduce this artifact? A, focal zone should be positioned in the superficial region. B, grayscale gain should be increased. C, color right priority should be increased. Or D, PRF should be increased. The answer is C, the color right priority should be increased. What you want to do is increase your color right priority, decrease your PRF, decrease your grayscale gain, and position your focal zone to more deeper regions. Question 35. Which of the following below was adjusted to make the image on the top look like the image on the bottom? A, wall filter increased. B, packet size increased. C, color gain decreased, or D, angle of inclination decreased. So what changed to make this image look like this image? The answer is B, packet size increased. The reason why you wouldn't want to increase your wall filter is because in this image, it would already be too high, demonstrated by the void of color. So you would decrease the wall filter to show this, or decrease your PRF. You don't want to increase your color gain because if you were to increase it enough to get just this part, the entire thing would be filled with color. And this one doesn't apply. And the angle of incidence wouldn't make the color Doppler this bad. But if you look closely at the color box here, see how wide that is compared to this one? The color box was obviously narrowed, which improved your color Doppler temporal resolution. If you run across a question that shows a wide color box with poor color Doppler, and in the other image, it looks like the sector was narrowed with better quality Doppler imaging, it's because that your temporal resolution increased. Question 36, and this will be our last question for this video. What does the backing layer do? A, provides a channel between the PCT and the ultrasound system, causing ultrasonic waves with vibration. B, provides similar impedance to the PCT crystal, allowing the pulse to move away from the patient. C, protects the patient from electrical shock as ultrasound transmits into the body. Or D, reduces ringing of the returning pulse by restricting the extent of the PCT deformation. The answer is D. It reduces ringing of the returning pulse by restricting the extent of the PCT deformation. Keep in mind that the backing layer and the damping material are the same thing. And this layer is made of epoxy resin impregnated with tungsten filaments. The main advantage of a backing layer is obviously it reduces the ringing, but reducing the ringing will improve your axial resolution, which is the most important resolution out of all of the resolution categories. Well, that concludes this test. I'll continue to write questions and upload videos as fast as I can. I'm Jim with ultrasoundboardreview.com. Thanks so much for watching.